I'd like to get started by introducing our speakers today. We have Stephen Comenia, the MemSQL Product Manager, and Hans Jespersen, Control Systems Engineer at Confluent. And they'll be speaking with you today about real-time analytics and IoT and a lot of exciting stuff. We will be hosting a Q&A after the presentation, so if you have any questions, hold on to them until after the presentation. Thank you.
Cool. All right. So hello, everyone. As Gene said, my name is Stephen Comenia. I'm Product Manager here at MemSQL. Product Manager means I work on the different products, and currently MemSQL offers a database product as well as a user interface product that sits on top of the database for management and monitoring, as well as a product around handling streams into MemSQL, which we call Streamliner. And Hans?
Yeah, I'm Hans Jespersen. I work for Confluent. I'm a systems engineer. I'm a customer-facing engineer. And we'll be talking later about the Confluent platform, but basically the company is the founders of Kafka. How many people here are Kafka users or new to Kafka? Okay, a little bit, so good. Yeah?
Cool. All right, so let's begin. So the topic for today is enabling real-time analytics for IoT. So that's a bit of a complicated statement, so let's break that down. Let's first talk about real-time analytics. So why is real-time analytics a big thing in the world today? Real-time analytics, you may have heard the term. It's a frequent buzzword that's been mentioned. But really this stems from, in our mind, three things. First, the fact that economy today is on demand, meaning people all have smartphones, people have devices, and people want to get insights about everything around them in real time, right now. Second, Internet of Things, which means I have a Fitbit right here, we all have cell phones, and even physical devices are phoning home, sending data back, and there's a huge amount of data that now exists in the world. And third, new technologies. So there have been technologies that are well suited to enabling real-time processing. And we'll go through a few examples today with MemSQL and Confluent. So MemSQL is a database that can handle real-time data coming in, real-time ingest, and also serve queries in real time. And maybe Hans here can talk a little bit about Confluent and the other use cases that are around IoT.
Yeah, sure. Actually, I appreciate this slide. This is I like the Tesla background. I'm a Tesla owner, and I've actually have a little side project of my own doing open source telemetry, getting live telemetry from Tesla. So it's, I think, about 4 updates per second that you'll get while you're driving or charging the car. Everything from what direction you're headed in, how much power you're using, battery consumption, speed, so on. And it's a kind of a great use case for the connected car, connected vehicle, as one of the kind of killer apps for IoT. But it could be a connected train, it could be a connected plane, Amtrak train trying to make sure it's not going faster than 50 miles an hour around a corner, right? These are the kind of use cases that people are instrumenting now, or connected factories, consumer electronic devices, right? Cameras and so on, security. Really, the sky's the limit on IoT. I know it's kind of a buzzword, but it is an exciting time to be in technology in this space.
Yep.
Okay.
Cool. So let's dive into the tech, right? Because this is the more interesting part. This is probably the reason why you're here. So given that you believe in IoT, that it's real, that it's happening today, you want to get real-time analytics on top of your IoT apps. How should you architect? How should you be thinking about architecting for real-time analytics? And our claim is the slide behind me, right? So the first big step is you need data producers. And these data producers already exist. These are the Fitbits on our watches. These are the sensors in cars. These are the sensors in your wind farms or wind turbines. These are the sensors in your supply chain. These then need to be digested by something that can handle things with great ingest, right? Then it needs to be transformed, and then it needs to be stored in a persistent mechanism that can handle queries very, very fast. And finally, it should be served to the users in an intuitive user interface, right? So this is the high-level architecture, but let's break down every single component of what I just said. So the first big component is you have data producers that exist. How do you handle it how do you handle all this ingest, right, in a message queue? And with that, I'll pass it back to Hans. To talk
Yeah,
about
yeah. So,
the platform
and
device.
sometimes these devices are talking directly in. A lot of times you're actually not allowed to connect directly to your device. So you don't directly talk to your Nest thermostat. You talk to Google's API, and it's a proxy into that endpoint, right? So there's a various different types of protocols that you'd be talking. It might be something as simple as HTTP, long polling, and a REST API that you're going after. But it also could be MQTT or CoAP or other kind of protocols that are designed for constrained devices where you're talking directly to those endpoints. So you need to have a flexible architecture where all these different protocols can be addressed, and no one particular protocol is going to be the IoT protocol that is for all of your inputs, right? So if you think of like Uber is going to be a connected car application, but it's also it's a cell phone application, right? So there's going to be various different gateways coming in, whether you're getting your data from the mobile device, or you're getting your data from a car, or you're getting your data from sort of a central fleet management system or something like that, right? So the data is all going to come in, has to be stored and persisted, and you need to be able to handle big peaks and spikes of data. A lot of times, like a car might be in a parking lot, it's disconnected, it drives out of that parking lot, suddenly it's got a burst of data that it's been collecting that it's sending in, right? So you got a lot of kind of bursty traffic that's coming in. You have to be able to handle that and not drop the bits on the floor. And you don't necessarily want to have to scale the entire back-end system to handle the peak load of ingest from all your devices. So you need to have this shock absorber or buffer that can handle these peaks, and this is something that Kafka is very good at. And then as the data is collected and buffered in there, then it can continue on downstream being processed in a pipeline where it's transformed and eventually acted upon. So a little bit about Confluent now, since I've started explaining. I want to first give you a bit of background on the company as well, so you know who Confluent is. You may know what Kafka is. Confluent was founded, we're coming up to about 2 years now, anniversary, founded by the original authors of Kafka while they were at LinkedIn. And today, over 70% of the commits to the Kafka framework come from Confluent staffers, so we think that's a pretty good mix, right? It means that the people who founded this technology are still very active in it, still moving it forward, but we have other people that are contributing, and it's actually a very healthy open source community. Not every open source community is this healthy, so I think it's a great place where we are right now. Let me see. That's probably about as much as I'm going to say on that one. We don't think of, in Confluent, we don't really think of ourselves as a messaging company, right? It's a streaming data platform. So it's much more than just being able to do publish and subscribe to topics, right? We think of the streaming data platform as being a framework that allows you, that allows you to build your applications, deploy your applications, monitor and manage your applications, right? So it's the full life cycle of streaming apps. And it's across real-time, sort of a millisecond latency kind of real-time applications, near real-time applications, and then also offline or batch. So we're unifying kind of batch and real-time all in one platform, and the full life cycle of these kind of apps. This is just an example of some of the kind of very popular apps that get deployed on the Confluent platform. You know, log data, activity streams from users and servers and machine data, database changes, so as being a commit log. The whole idea of Kafka is to reimagine messaging as a commit log, right? So it's a natural fit with database technologies. And then, of course, what we're talking about today, so sensor data and acting across on sensor data.
Excuse me. Have you heard of people kind of serving up web pages in the, kind of like in the background as well with Kafka, or is that not a?
Well, collecting activity data from web pages, so as a user is interacting with a web page, that's a very common.
To that web page.
Without any responses, yes. Yeah, so if you just want to have a heat map of like how people are clicking or moving around their mouse, and maybe they're not even clicking on anything on your web page, but this is telemetry that you can get from the tooling in the web pages or the web servers, all that data can flow through.
Sort of like response information, like somebody requests something that kind of transpires through the database and comes back?
Yes,
Is that
yeah.
something?
Absolutely, yeah. So we started here because of the IoT demo and the use case we're showing. We're talking about Kafka as an ingestion pipeline, but it's just as easily, sending data back out. And we can talk about that in the context of IoT. But yeah, absolutely. That would, yeah, no, that's fine. So these are the components. If you're familiar with Apache Kafka, and you go to the Apache website, you can download what we would call kind of the core platform. So this is the message broker itself, a Kafka Connect components, which is a framework to make it a lot easier for you to build adapters or connectors for sources and sinks of data and to configure them with no coding. So that's in there as well. There is a Java client, which is the main client library for developers. And then we've just added now this Kafka Streams component. So this is the ability to do inline transformation and other processing, streams processing, directly inside of the Kafka framework. Now, Confluent then has expanded that to include other open source technologies. So this is all completely open source. If you're a developer, you can go to our website and you can download clients for C and Python and other languages. This is expanding as well, and these are native wire protocol, Kafka wire protocol clients. For C is very popular, for example, in financial services, where you might want to be doing very high speed or low latency kind of applications. There's a REST proxy as well, which is very interesting for IoT, because it means that any application written in any programming language running on any kind of device, if it can do an HTTP post or an HTTP GET, it can be sending and receiving streams of data into Kafka, right? You don't have to put the Kafka client API on your Raspberry Pi to make it publish something, right? Yeah. You can, but you might not want to. There's a schema registry as well, which allows you to describe the data that's moving around and ensure that any information that you're ingesting is valid. And if something is supposed to be an integer, it's an integer. And you're not sending bad data in and then ingesting it and having to deal with it later on in the pipeline. You can reject that right away, and then those applications will know that they need to be reprogrammed, right? And then we have pre-built connectors for various different systems, including one that we use for MemSQL, which we'll be talking about, and then a control center, which is kind of a dashboard, a graphical dashboard that can watch over all of these components in your system. Okay? So this is what it would look like in an architecture. You're going to have sources and sinks of information, in this case, MemSQL as a source, or we're going to show it as a sink in this particular demo. IoT data coming in either directly into the native APIs or through REST proxies or other proxies and other connectors, all being managed by the control center. And then, of course, consulting services and that, which is the main thing that we sell. Okay? This is an example here of the control center dashboard. It allows you to configure all the sources and sinks of information. You can see sort of the latency here of the data from end to end as it's flowing through the pipeline and do alerts off of that. You can make sure that all the data is actually arriving, that there aren't any slow consumers, nobody's losing data or falling behind in the data stream. And so this is the primary dashboard for monitoring and managing everything within the whole Confluent platform. All right? So tying it back in here to our architecture that we had before, you have your IoT devices out here, the fog layer or the field layer. They might be gateways. You might even have other little message brokers on these devices. Like in a Tesla car, you probably have several hundred different sensors, but they're all flowing through kind of a sensor gateway. And there's multiple gateways depending on whether you're talking about kind of the entertainment system that the user can access or the internal systems that the users shouldn't be able to access, right? And then you might even have things like a little MQTT broker, like a Mosquito or something, running on those devices, aggregating data and storing it up. And then you can go through the various different Confluent or open source third-party adapters, connectors, excuse me, WebSockets, MQTT, CoAP, REST, so on. And then that flows into a Kafka cluster, all right? And that's the primary distributed message queue for ingesting and transforming your data. Okay?
Cool. One other thing to call out here is notice how these arrows are pointing not only to the streaming data platform, but also back from it. So you can see that, depending on what sort of producers are producing data, you can do some level of data movement within here and pass it back in case you want to do decision making. Moreover, you can imagine, as we talk about the rest of this architecture, the producers going all the way to the database and maybe even the UI, decisions being made, and then it getting sent all the way back to make decisions on devices at the edge. So there's a lot of like really cool applications around here.
There are no arrows.
Sorry?
No arrows.
Yeah, I know the arrows.
Oh yeah,
The
we
arrows
need
should
to
go
draw
back.
arrows both ways.
I think in IoT, kind of IoT phase 1 is device to data center.
Yes.
You're collecting all this data, you're sending it all into the data center, and you're doing analytics on it, and you're getting some insight. Then the question is, well, what are you going to do with that insight, right? Are you going to send out a memo, or are you actually going to make it an actionable event? And that's when IoT starts going the other way. And instead of sensors, you're talking about actuators and things that are out here. So your insight that you're getting, your real-time insight is saying, I think my gas pipeline is leaking. Now I better send out a signal that says, turn off that valve, right? Or slow down that train or something like that. So that's really where the bidirectional nature comes in,
Would
right?
argue the valve would be on the other side.
Correct.
Yeah, it
So
could be. It could be.
Both
Yeah.
things could be done, right? So as you'll see in the demo later, actually, you'll see a user interface, and you can also imagine that this UI shows a visualization of how your system is doing. That could affect the producers on the other end. Yes, sir?
You're saying that there's producers and consumers right there.
There is, I mean, these are the producers, right?
When it's coming back, it's a consumer. Yes.
When it's coming back, yeah, you can see it as a consumer as well. So the next thing that you need, right? So we talked about this phase, right? The message queue, the gateways in front of it, and the data producers is a database, right? The next big box here is a database that can handle all that data coming in, right? There's a lot of data streaming in from sensors. There's analysis that needs to be done. You need a database to be able to handle it. So with that, we'll talk about our company here, MemSQL. How many people are familiar with MemSQL? Awesome. OK, great. I will fly through this part. So MemSQL, the first big thing to note, it is a relational database. It is a SQL database. So we are not a NoSQL database. We are not a SQL on Hadoop. We are a full-fledged relational ANSI SQL database. The unique value of MemSQL, right, is that it is in memory. It runs, we have an in-memory row store, which can handle like a lot of transactions. Furthermore, we actually have a in-memory and disk column store. So we actually have both a memory row store and a memory plus disk column store. This allows us to handle transactional type workloads as well as analytical type workloads in the same system. Third big piece, which is also a big differentiating factor, is that MemSQL is distributed. So you have SQL, you have it running in memory, and you have a shared nothing architecture, right? So that means when you have peak workloads, you can easily add nodes. When nodes go down, your system doesn't go down because you can maintain high availability by maintaining replicas across your cluster. And finally, the final point here is that it's flexible. It runs on VMs, containers, on-premises, or in the cloud. So that makes it a simple system, familiar system with SQL, real-time, low-cost, and flexible. Pretty simple. I won't really discuss this slide. If you're interested, we can chat later. But for the purposes of it, there are a few technological innovations that we've done here at MemSQL to take advantage of the fact that we are in memory and for us to integrate better with the ecosystem. Examples of which are, we use the MySQL wire protocol, which means if you have a system that can connect to a MySQL database, you can connect to MemSQL. Just change the host name, and that's it. Other things we do, we have code compilation, which means when a query is run, we actually generate the instructions of how to execute that query all the way down to machine code, which means in subsequent executions, it is very, very fast. And this isn't the same as a prepared statement. This is all the way down in machine code. And we have a bunch of papers and some blog posts if you would like to know about how we do that. Third big innovation that I can call out here is distributed joins. If you have a system that's shared nothing, and you're calling a SQL, a complex SQL join across it, it is non-trivial to be able to ship the records around and return a query result. It is a very hard technological problem that we have solved here. And finally, one other thing to call out is we support JSON data types. So you can store JSON in the row store or the column store, and geospatial data types. And our demo will actually go through geo. And by geo, I mean points, lines, polygons, measurement functions, and the use cases of that are around transportation, around supply chain logistics, and various other things. Another thing that we have here as part of our piece is a transformation piece. So what we discussed with the Confluent platform is that you can do some level of data moving inside here. You can pass it to systems, and you can pass it back. With MemSQL, we have an integrated Apache Spark solution. So we can actually deploy Apache Spark for you, and then you can use Spark as your real-time ETL tool. Why did we pick Spark? Well, we realized that MemSQL is in-memory distributed SQL. Spark is in-memory distributed general computation platform. There's a lot of ways that we can tie those two systems together. And one thing to call out about our Spark integration is that it's open sourced, and you can download it, and you can install it on your Spark cluster and connect it to the MemSQL UI. So just to end with this slide, you can see here in the middle is where MemSQL is. We have a row store. We have a column store. We support relational. We support JSON. We support geospatial. You can create a way to feed real-time data pipelines in. We can connect to various sources and also various syncs as well if you have a BI tool or a real-time app on the other end. So let's go back, because this is the key architecture slide, right? So we talked about this piece. Now we've talked about what MemSQL provides. Now, the last piece is a user interface. Let's tie it all together. Let's give it some beef. Let's talk about a real-time application. So the demo that we're going to show you today is what we call Memex. And Memex is named kind of after FedEx, which is a delivery, it can deliver, and it's around supply chain. So this application combines MemSQL, Confluent Kafka, and Spark to show how global supply chain management could be. So what we actually do is we model, we have a map, and I'll show you in a little bit, that shows warehouses, which each store a supply of goods. And inside each of these warehouses are specific, the warehouses have to produce goods. And the way they produce goods is through devices that have sensors and data points in them. And these data points are 2 million, so we have 2 million data points being produced in the demo with 2,000 sensors across 1,000 warehouses across the world. So this is a demo that exists, and we will show you right now. One other piece to call out, now that I see the slide, with Memex is that we chose to use Spark as a transformation tool in the middle because of the fact that we can do things in Spark like leverage MLlib. So what we can do is do a very simple machine learning algorithm where you have sensors that simulate data from those warehouses, indicating their ability to produce a certain good. They're getting passed into Kafka. Here, we can calculate a feature vector based on the sensor data coming in. The feature vector and the sensor data are then getting transformed in Spark, where inside Spark, we map that to a linear regression model. So we try to see how the machine or the producers degrade over time and get repaired, and degrade over time and get repaired. And we kind of map that behavior to be able to predict. So what we're doing here is we're trying to predict how these producers or how these sensors over here, their ability to produce over time. And we can model that with a certain regression model in Spark, pass that to MemSQL, and visualize that in a UI. So what I'll do here is I'll show you the UI. And we can, basically this slide shows that as we are deciphering the model and trying to see how the producers are doing, we can map it into a state where it's doing well, a state where it's not doing well, and a state where it's doing sort of, kind of well. So this is just a general classification diagram. So let's go through the demo, since that's an interesting piece. And again, after this meetup, Hans and I will be available to show you demos of other stuff. I can show you more MemSQL. Hans can show you more Kafka, more Confluent, and you can show, like, if there are any questions here, feel free to ask us after. So let's go to the demo. Requires a password.
So I think this whole idea of kind of predictive maintenance and monitoring is very popular right now. And I mean, it doesn't have to be factories. It can be obviously anything. It can be jet engines, or it can be, in this case, the assets are fixed because they're factories, but this could be moving around as well, right? So you can do optimizations and predictions based on, geospatially as well.
Yeah.
So with machine learning,
Yeah.
So
There's different types, there's different algorithms and different types that, yeah, that would be one of them, where you're looking for a repeating pattern, or you could just be doing,
so this is like prediction basically, right?
yes,
Like,
yeah.
Correct. So I can explain a little more here. So here you can see, I don't know if you noticed, like I can move around this map. I won't move around it too much, just for the sake of, keeping the view fixed. But you can see these represent these represent warehouses, and you can tell how those warehouses or facilities are doing. So green means doing well, yellow means not so well, red means like not well at all, right? And how do we calculate this, right? That's where the whole model comes in, and we can talk offline. Like I don't want to talk necessarily in this demo about how that's calculated. Within this, you can see that we have alerts showing up containing different parts of the world, how those different warehouses in different parts of the world are doing. Whenever I move around this map, this actually fires a geospatial query to find out all the facilities within this like LON-LAT range and plot them here in this map. The green, the yellow, and the red is based on the algorithm that we use for modeling how they're doing. And one big thing to call out here is you're seeing like 2 million, 1 point something million, a bunch, like you're seeing a lot of records coming in to Kafka every second. And the way we're able to do this is by having a system that supports real time all the way, right? Producers that produce a lot, Confluent that can consume a lot of things, and MemSQL that can store a lot of things and show it in the graphical UI. Another thing to call out here is that as I zoom in and out, so I can actually, let's say, pick Detroit and just go all the way into Detroit. And you should see, all right, let's keep going. There you go. So you should see that from facilities, it turned into sensor groups. And in these sensor groups, each one of these represents the ability of that facility to produce the good. And these change from yellow to green to red depending on how the data points are coming in and mapped to that particular model. And basically, this we are firing a query to the database that will only map this particular area. And if it senses that it's really close to a warehouse, then it'll start plotting the gears instead. So as you can see, reds show up every so often. So one last thing to call about the demo is that these lines, since this is Memex after all, represent the ability to deliver goods across to the different places and different routes that if this was a theoretical FedEx, you could take to be able to help this yellow factory or this green factory serve the yellow factories in terms of goods delivery. Okay, so one last thing that I guess we can call out is there is MemSQL Ops is our, not on this browser. MemSQL Ops is our graphical management and monitoring user interface. And inside Ops, you can see the status of all the different machines that are running MemSQL. So what we've done is we have Kafka, we have MemSQL, we have the producers, all in an AWS environment running 16 nodes total and 8 machines total, and processing 2 million records. And with that, Q&A. So any questions? Otherwise, we are here after to answer your questions as well. Yes, sir?
Can you clarify what the reads per second correspond to? Is that just for the query zone that you had on the UI, or is it some other part?
Let me go back. Why did I? Yeah. So the question was, could we clarify these reads per second? These reads per second represent how many reads we had to do to generate all the data points here in this map. And what we'd actually have to do is find out the LON-LAT and then figure out, OK, within that, what are the gears? How are they doing? And to be able to color all these pieces. Yep. Yeah, so the prediction is actually like buried in like how it's colored. So you see Vegas right now is color red. Color yellow now. Basically, each of the sensors within each of these facilities are emitting data, putting it in Kafka. A feature vector is created, fed to Spark. That's where we execute the machine learning algorithm to be able to learn or to be able to model how we think the facility is going to do. So the color actually doesn't represent the absolute state of the facility. It represents where we think the facility is going to be in a short amount of time. Yep. Does MemSQL HA? Yes, you can configure MemSQL to duplicate data in the cluster. So what we have is you can set up MemSQL's architecture is an aggregator tier where you can query and a leaf tier where you can store, and these leaves can be configured to be redundant.
And you can do the same thing for the
And you can,
ingestion layer, right?
yeah.
So as your data is coming in, Kafka can be configured to have multiple data centers and be replicating data to multiple instances, which may look the same, but they might also be different. Right? You might have aggregation hubs and satellite deployments that just work on a subset of it.
So the idea, going back to the, we don't need to go to the slide, but there is high availability built into the model at the Confluent, at the Kafka tier, and also at the database tier to be able to retain data throughout that entire process. Yes, sir.
Is this imaginary, or do you guys partner with that FedEx?
Is this imaginary or partner with FedEx? This is a demo we built here. So this is a demo we built here. We've built other similar demos, and a bunch of customers have actually watched our demos and become customers because of some of the demos we built. So
But the reading and writing capacities are real.
the reading writing capacities are based on actual Python producers pumping it into Kafka, storing it into MemSQL. So those are real numbers running in the back. That's why you can see, like, it fluctuates to different values, right?
We actually have there's a bunch of Kafka customers that are now what we call the 4 comma club, which means they're doing over 1 trillion messages per day. So you're talking about many, many, many millions of messages per second ingestion capability. So it's great to have a database that can handle that kind of data load, because it's actually possible to capture those kind of that scale of data today.
Yes, sir.
Are you co-locating Spark on top of this?
Are we co-locating Spark on top of MemSQL? For this demo, yes. In practice, the customers that we have typically separate it.
Could you speak to Confluent and all the modules you had? And I know this is theoretical, but what could be done here out of all the layering that you do on top of just the generic Kafka? So I know Confluent could put down.
Right.
Could you repeat the question, actually? For the,
Yeah. So the question is, if I can paraphrase it, tell me if I get it right. The differences between the base Apache Kafka and then the other components that come from Confluent and sort of.
And what you might do in that scenario. So
Right.
here's why Confluent, and here's how we could use it.
Yeah.
Here's how we are using it.
Yeah, I think the thing that we focus on is making the core Kafka, enhancing it in a way that just makes it easier to deploy, easier to manage in kind of a mission critical enterprise environment, right? So you can do all kinds of things with the core Kafka without any of the other Confluent components. And in fact, a lot of the Confluent components themselves are also open source, right? So you can use those, you can download and use those yourself. But where we add kind of enterprise capabilities, it's always around making it easier to deploy, making it easier to manage, optimizing your deployment so you're using better, efficient use of the servers that you have. And
So for the purposes of the demo, you could have had additional clients coming from something like it says there on the bullet point, additional clients. You could be
Correct.
data, but
Oh, yeah,
they
the
just weren't for the demo.
yeah, for the
Correct.
demo, it's Python, and that happens to be one of the components that is a Confluent component, but it could be written in any other programming language or come through any proxy or any
And we could have easily built it calling REST APIs or using MQTT as a protocol. Yep.
Yeah, the schema registry is an Avro-based schema registry, but it has a lot of optimizations in it, right? So with Avro, you typically have your schema and you have your data, right? And you would ship that with every single message. Now you're adding a lot of extra overhead if you were doing that on a message-by-message basis. So what the schema registry lets you do is you put that schema once in the Confluent schema registry, and the client libraries will actually cache that schema registry, and in the messages you'll just be sending an ID. So it's schema 1, right? And that'll look up, and it won't be constantly querying your schema registry to figure out what schema 1 looks like. So it's a much more efficient way of doing Avro versus, kind of just putting it all together in line with the message. Yeah.
All right. We can probably take one more question, and then we'll break out. We're here. There are a few MemSQL engineers here, and there are a few resources from Confluent as well. So, yeah.
Well, I actually have 2 questions.
Okay, 2 questions. We'll take 2 more. Yeah.
What do you mean by connector management and stream monitoring?
So the connector framework will allow you to,
You can go to the next slide as well if you feel like.
what's on the next slide?
This view.
Oh, yeah. So you'll have two different types of connectors, sources and sinks. And typically what you'll do is you'll deploy these and you'll start them up on, they might be co-located with your source data, or they might be on separate machines from those systems. But once a connector has been started, it has all the logic that it needs to know how to connect both to Kafka and to the source of the sink system. So then through the control center interface, you can now go in and graphically start multiple copies or configure it differently to say I want to publish to a certain topic name or I want to listen to a certain topic name. And all of those things can be changed with no extra coding whatsoever, right? So where if you otherwise were writing applications that talk directly to the Kafka client API, every time you wanted to make some of these changes, you're going to have to shut it down, reconfigure at least, maybe even recode some of your applications and start it back up again. So there's a whole set of connectors that come from Confluent, and then there's a open source community where a lot of them are being posted on GitHub. So we host a connector hub page where you can go in and see all of the different connectors, and a lot of them have been certified by us as well, so you know that they meet a certain level of quality and they actually work, and some of them are commercially supported by third parties as well. So that's what this whole framework is for.
Right.
Okay.
The second question I have is, how does Confluent, where does Mesosphere come in?
Okay.
I think I read.
Yeah, so we made an announcement recently with Mesosphere. I think that this kind of platform does fit really well with a microservices architecture, right? Because all of these components are running on different machines, and they're all scalable, right? You could start multiple connectors or multiple streams processes, and in fact, you could do this elastically, right? You could have streams modules that are expanding as lots of messages come in and then contracting to a smaller number when your peak has passed, right? So Mesosphere and other microservices architectures or infrastructure as a service and platform as a service architectures make it really easy to automatically start up and scale back lots of instances of all of these processes. And the value that Kafka brings is that it's built into the whole architecture, that it's very easy to just start up, partition, and start up new instances and scale them up and down. So it's a natural fit between those two. Okay.
Cool. Okay. Well, thank you guys so much for your time. Feel free to hang out. There's still a lot of food, and Hans and I will be here. And as I said, there's other resources here as well from MSQL and Confluent to chat about any parts of this demo. And great. Thank you so much.